So streamline flow is smooth air over a surface. It's not, I shouldn't say air, smooth fluid over a surface. We usually think of it as air, though. And if you have your wing, it's just the nice continuous lines of air over the surface. Turbulent flow is rough air, rough fluid over a surface. And that was something that looked more like this. So you still had some air that was kind of smooth flowing, but then when it got to the back end, it kind of got messy. Okay. So what's mass flow rate and the continuity principle? So mass flow rate is literally the rate mass flows over a surface. And the continuity principle is mass flow rate is constant. So the amount of stuff that flows over a surface is going to be constant. So the amount of stuff that flows over a surface is going to be constant. So that gets into number 4. What effect does mass flow rate have on the velocity? So the velocity changes to keep the mass flow rate constant. So velocity changes So the velocity changes to keep the mass flow rate constant. Okay, so a somewhat helpful analogy. Mildly, I found that some people find this helpful. It's an analogy that I think is helpful. We'll see if you find it helpful or not. Did I get rid of it? That'd be so sad. Sad. Okay, anyway, here's the example. Ticket booth at Disney. Okay. This is a really weird Disney. Okay, this is Disney Australia. They do things a little weird down in Disney Australia. So in most Disney World, they just let in as many people as they can. In this Disney World, they only let 100 people through every minute. Let's just say that. 100, that's ridiculous. They let 10 people through every minute. Okay? 10 people through every minute. But that's the rule. It has to be 10 people a minute. Absolutely. 10 people a minute, no one more than that. So if you have one ticket taker open, how many people do they let through in a minute? 10. Right? So they have to do it once every 6 seconds. They have to let a new person through once every 6 seconds. What if I have 10 booths open? Then they let one person through. And how long does it take that one person to get through? 60 seconds. So here's how this works with velocity. The amount of stuff that travels through depends on the velocity that they travel depends on how much can get through. So Disney, so if you have 10 people per minute, So if you have, we'll just do, I can't draw 10 booths, but if you have 5 booths open, it'll take 30 seconds per person. But if you have 1 booth open, it'll take 6 seconds per person. So we can see a relationship here. The wider something is, the more stuff that can get through, the slower it goes. So the more stuff that can get through, the slower it goes through that. And you've all noticed this before, okay? You ever put your thumb over the end of the garden hose? Yeah. What happens to the water that comes out? It goes super fast, right? And if you take your thumb off, it doesn't go as fast. That's the exact sound it makes too. Okay? So, when we make things narrower, they go faster. When we make things wider, they go slower. Okay? So water is traveling through a pipe with a diameter of 1 meter with a velocity of 0.5 meters per second. What would the velocity be if the pipe narrowed to a diameter of 10 centimeters? So here is the pipe. Okay? So this has a diameter of 1 meter. This has a diameter of 0.1 meters. Yeah. Okay? So, we need an equation for this. And the equation is the following. Density of the fluid at position 1, so this is position 1, this is position 2. Density at position 1 times the velocity at position 1 times the area of position 1 equals the density at 2, the velocity at 2 times the area at 2. So, it's water. Does it ever change from being water? No. So the densities don't matter. They're the same. So you can cancel out the density. Okay, what's the velocity at the beginning? 0.5. What's the area? It's a circular pipe, so it's pi r squared. So it's pi times the radius, which the radius is half the diameter, so it's pi times 0.5 squared. Equals the velocity at 2 times the area at 2, which is pi r squared, but its diameter is 0.05. So 0.5 squared times pi times 0.5 gives me 0.39 equals V times 0.05 squared times pi. 7/8. Divide that to both sides. Yep. 0.0078. 0.0078. .39 divided by 0.0078. Velocity is 50 meters per second. There you go. Simple enough. And that's how you calculate how much things will speed up or slow down or change by. Yep.
What's an instance where it doesn't say water, or like the
Oh, so there's things called compressible fluids. So compressible fluids, if you squish them together, they become more dense. So a perfect example of this is air. So air is a compressible fluid. So if you have a bottle filled with air, you can squish the air together and it'll make it more dense. So this only works well for things that are called incompressible, which water is incompressible. Like if you have a full thing of water, like this is pretty much all the way full, I can't compress this very much except for the air part. So that's the idea. It's an excellent question, Sam. All right, Bernoulli's principle. It's demo time. I have a bag. It's a very large bag. Okay. I am going to fill this bag with air in one breath. All right. So how should I fill it? Like, what's the best way for me to get as much air in here in one breath as possible?
An air compressor.
Okay. One breath. One breath. In through my nose, out through my mouth. Okay. But like, what should I do? Like, just like that.
Do this, like,
Oh, crumple it up and like put it over my mouth, something like that? Okay. So I'm going to crumple it up. I'm going to put it over my mouth. I'm going to keep any of the air from getting out. I'm going to take one huge breath. I'm going to blow it in and see what we get. Okay. Not bad. That's how much air I got in. Pretty good? Pretty good. I can do better than that.
I have an idea.
Okay. I'm going to do the exact same thing, except not. I'm going to hold it open. I'm going to stand away from it, and I'm going to blow into it. Okay? Ready? Here we go. 1, 2, 3. Impressed? Impressed? So, why did this happen? So this is something called Bernoulli's principle. Bernoulli's principle has to do with pressure. Specifically, it has to do with pressure of fluids when they travel at different velocities. And here is what it is. You know what? Let's pause this.